Okay, so probably we can start. Good morning and good evening for some of you, and welcome to the second series of our Mark Forge webinars. And today we're talking about food and packaging. So today, together with me, we will have another speaker, Adam Taylor, who is the government incentive introducer in Ernst and Young company, and he later after my presentation, he's going to introduce about some government incentive in Australia that can help food and beverage industry to leverage on those new technology like Markforged. So let's get started. So before jumping to industry, I just want to mention that we are right now is kind of in a post-COVID situation period. And still you would say although it's have some a little bit pause on the pace on growing or improving on the economy, but it's still be able to see we're still living in a very dynamic world, and it's a very rapid changing preference, and you can see your customer or consumer demands will be require a lot of time need to have an even faster supply chain supply, and also some very niche business. It only can be grow through if you have more offering, or if you have highly customized for your very little or very segmented market segmentation. And also pandemic drives a lot of new products grow or come out to face the world, and to try to eat the pie with some big players. And validate labor condition. A lot of time you will see skilled labors, for example, like a current conventional manufacturing skilled labor, CNC machinists. It's very hard to find them, and incoming next generation workforce for manufacturing is a lack of talent for at this moment for a lot of developed country. And the pandemic also introduced a new labor working constraint. You don't have a lot of people that, or even government doesn't allow you to let your workers to go to factory like all the time, like periods before COVID come. And also supply chain, you have a lot of constraints, right? So it's instability of OEM parts. Whenever they have breakdown, you have to wait for that. And if your OEM is from overseas, you have to wait previously maybe weeks, but now because COVID, you need to wait for a month. And reliance on third-party supplier to get a single point of failure choke points. And also pandemic has uncovered kinks in the supply chain and need for more adaptable manufacturing process. So in the supply chain itself, they're not as resilient as we once thought. Some thing or some news, especially last year, you see people see a lot of factory shut down, and the labor cannot work or don't want to work for manufacturing or factories, and continental logistics break, and they are one point failure, and the whole point is failure for the whole supply chain, and inhibited our ability to get basic items like bleach and toilet paper. People rush for those days in supermarket, and no redundancy in the supply stream architecture. So the whole chain, once there's one small point breakdown, it affects everybody in the chain. So it's very difficult time for the traditional supply chain facing, and unsuitable emergency response mechanism. Example like the shield or the face masks. Suddenly a lot of people switch to manufacture those things because there's extremely a huge spike on using those things, and they have to switch their supply chain because they add this new product, or they change the bread and butter from their original product to the face mask. And it could be very untenable to stock supplies for responding to all the out of sudden disaster scenarios. And also insufficient response to demand signal. a long lead time makes this almost impossible to make more or something new as quick as what market is desired, and also slow to adopt the new product requirement. So it's same as it will be same as most all the other industry like food and beverage also have this kind of constraint. And if we put the supply chain, the chain itself, it starts from manufacturing and move to distribution, and then you have a regional hub to distribute it locally, and the regionally shipping by your by some logistic company, and then point of need the end customer will receive that. And in fact, because COVID and right now we're in the post-COVID, the supply chain demand is actually higher, but the supply itself is actually getting more difficult to do that. And it could happen for food and beverage manufacturing factories or company that sometimes you need like a prototype or tooling from supply chain. Sometimes you need an MRO or spare parts for your manufacturer conveyor for some of the parts. Or sometimes you maybe just want to have like a small volume production, not as a mass production as your packaging thing. They all still have to go through this at least simplified 5-step for the whole supply chain in different manner. But what we see in Markforged is that in the future actually either can be prototype or tooling, or some spare parts in your manufacturing line, or some unused part, the small volume production. You can all be thinking about using a cloud-based software and just sending the parts through cloud via internet, and so that you can have the actual part itself, the unused part or the tooling part on site by using the printer to print it out. And that gives you a modern manufacturer, or we call modern manufacturing method, and that require a more modern equipment. And that this method actually gives you a smarter way, a more connected way that you can, in a way, indirectly eliminate part of the supply chain, less relying on the part of your current supply chain. And it's very easy on accessing all the parts or all the component that you require just through online in digital manner, and it can be easily be scalable. If you can do that in Australia, you definitely can do that in Singapore, and definitely you can do that in Japan as well. And that is this is a common a picture that we will see in the mineral water manufacturing plant, and part of it is like a portion of just finishing the bottle manufacturing, the filling and closing the cap and going to put it into boxes, carton boxes. So we will use that picture in the later case study way, but just give you an idea that this is something, or this is some situation or scenario we will see very often, and we definitely can help. Markforged technology definitely can help on supporting those kind of customers. So if you do have something similar in your factory lines, you should pay attention for the next few slides. Okay, so back to the main topic, we talk about packaging. So first of all, what is packaging? So packaging is the planning, creating, manufacturing, wrapping, boxing, or bottling of goods of consumer, industrial, and for consumer, industrial, and the military markets. And the packaging industry, in fact, plays a role in nearly all the industry and the manufacturing established. So whatever products, the tangible products you have on your hand, they all kind of give together with some packaging method. So to simplify the whole background about the packaging, you can see actually at the first stage, packaging itself, the major purpose is only used for transportation and storage to protect the actual products inside the boxes. Then the second stage is people start to see that there's actually some value, or you can bring some marketing awareness by using packaging, so that they put their logos or their some key features on top of the surface of their packaging. And then thirdly, in the stage 3, some people see that some factories like Lok, they see there's actually a market needs for use professional packaging on different use. So they actually, the packaging itself or the box itself become a product, right? And in the stage 4, a lot of mass production, actually they require a mass production on packaging itself. And that's actually a very huge industry, and that they have their own supply chain on building those packaging on the stage 4 for mass productions. And also the packaging in different industry, you could see very different outlook. So food and beverage is in this manner, and then some consumer goods I put it here is a toothbrush. You can see some different way or different material or definitely different look packaging versus food and beverage. And in terms of functionality, like for example, military, some casing for putting the bullet, it's like a more niche market, and the purpose required for these 3 industries, you can see they have dramatic differences, but they are all generally considered as they have their own different packaging consideration and packaging features. So in this, for this market, and just putting an example for 2020, on a global scale, the packaging industry is enormous economic generator. Statistics from the well-organized Smith-Perra organization indicate the demand of the whole world packaging industry will reach to 1+ trillion by 2024. And the consumer trends and factory trends for packaging drive the gigantic growth rate. And there's definitely say a lot of different trends, but here I just highlighted one of the trends that probably is matched with what we're talking today, is the personalized packaging. It's one of the biggest trends from 2020 to 2024 in packaging industries. And definitely you see a lot of F&B, the big players, they keep coming out, like the period is become shorter and shorter, and they keep coming out the new things, new package or new product, or maybe somehow they just change the package and say this is a new version. And here's some example, like Coca-Cola, they print people's name on their soft drink container, and Frito-Lay print faces on their potato chips package, and Bud Lights printing football teams promotion on their big beer cans. So all this packaging production now is in the F&B actually requires more flexible or more agile supply chain to support all those new product or new packaging design. Okay, so talking about Markforged, we are a 3D printing company. So in what kind of ways that 3D printing or Markforged can help on F&B packaging in general? So here actually I split out different ways of using Markforged on packaging aspects. So let's go through one by one. So first of all is the packaging about prototypes. As I mentioned in the supply chain, the yellow color slides, I mentioned that sometimes the prototype requires your certain supply chain or your vendor to give you that. But right now, actually, you can use 3D print to print it out. And not just strong for our parts. Markforged is famous at printing strong parts, but also we can print some flexible parts, or even like some a little bit complex geometry like the hinges. It can be printed out and used. And yeah, so and the cost of using that is just the material cost itself, and the printing time is fairly depends on the size of the part you want to print. And just now I showed this hinge itself. There's no post assembly, and during printing is like that already. And you just take it out from your printer, then you can still see the functionality or your prototypes, the foam feed requirement that you have, and they only cost maybe a few hours. In the daytime, morning you print, and afternoon you will have the part. Right. Another one is in the food packaging, the material itself we have two material that actually can be used, apply on some food contact or indirect food contact scenario. One is nylon. So nylon is a very common known used material for different kind of ways of using in food manufacturing. And here is actually Lipton. They use our nylon material for the tea bag cutter. So there's like still you buy the tea bag in a row, but between different tea bag you have the dash lines, and that is cut by, in this particular production line, that is cut by our nylon material. And also in our metal system, we have 17-4 stainless steel, and also that is safe and durable to use in food industry. Or even more, we have once you go to more advanced conveyor or the lines, you will see a lot of like interactive robot. And sometimes those robots can do things during COVID by themselves. But different, even same model of robot, if you ask them to do different tasks, you need to require different kind of tooling. Now, for example, here the white color thing is actually a folder for folding the box and also seal the box. And also underneath that, you can see some. I'm not sure if you can see that. Is some black color vacuum sucker, and those are the things that actually use a vacuum to hold those curtain box to the place for doing all those jobs. So the benefit of using our material is that our printing technology actually can print some internal cooling channel, which different from what you see at here, because right now you see the blue colors tubes. They are actually the tubes for deliver the vacuum suction. But by using our material itself, you can put those internal channel, or you can insert those vacuum channel through the parts, the original white parts here, so that you can hide all the tubes and make the whole working environment more tidy, and also the efficiency is better. All right, so there is gripper, and for holding with the vacuum. Also here is another one, is just a customized end effectors to holding this pallet from one place to another. So different pallet, probably you need to have different this black color thing to do the job, and the 3D printing can help to do that. And the reason Markforged is a better one is because our material is way durable than the normal FDM or FFF material that you see in the market. It can last for a very long time to use. Right. And next one is the parts in conveyor. Simple parts. Just now we talked about some advanced parts or some highly customized parts for your product or for your packaging lines, but still in some general parts like a roller or gear, gauge, socket, or O-rings. Those are the things that probably right now you still have to purchase from your OEM, and they are very simple geometry, and they're not supposed to be that costly, but because you have this whole production line purchased from an OEM, then they say you have to use their own spare part to make sure the performance. But at this part of time, actually a lot of people don't want to tie down so much with their own suppliers, but try to think about a more innovative way by doing by themselves, DIY those parts. And it's not just a trend, it's already happened, and people doing that and get benefit from there a lot. Like we have a few customers that have factories in Southeast Asia region, and you're supposed to get the parts from Europe, but right now actually they can try to use 3D printing and do this in-house with a day and to replace the part to make sure the conveyor still works smoothly with way less shutdown time just waiting for one part. Another supply chain is another application is a little bit more indirect application, and here we are talking about the plastic on blow molding on the containers, on the bottles. This is a very great application for our industrial series, because the industrial series, the printing platform is slightly is a few more bigger than the desktop series. So here is what I'm talking about is we can print some mold for blow molding. So if you're not very familiar about blow molding, here is the principle about this manufacturing process. So create the mold, and you have the original, the bottle parts looks like a tube. Then use the high temperature air to blow it. Then you will have the shape. And in order to form the shape, the outside, the pattern is required. And what I'm saying is we can print those patterns as a pair and use into this blow molding part. And from what I understand, usually F&B factories do not manufacturing molds, but they need to purchase from their vendor. And if their vendor can't deliver on time, then all those manufacturing process need to wait just for a pair of mold. And sometimes the mold also may have some error or have some failure, then you need to request another second one. So for a quick mold, quick turnover mold, you can think about using 3D printing to fabricate the pair of mold in a faster manner. Okay, another type of packaging is a paper bulk. And the paper bulk also need to form the shape. And you can see here is this is the final paper bulk package. And here is the mold that you can use 3D printing to print it out. So the purpose of using that is there's 4 different ways. The one benefit is for the designs in holes and porosities, because paper bulk is slightly different from other molding. You still need to have some tiny holes or have some patterns for them to better adhere together. So it requires holes and a certain porosity. And the porosity is actually our strength. We can print parts. We can print out the parts in like porosity inside the part itself, so that it can run like just now mentioned the vacuum in the robot, or like some certain suctions, so that it can help the adhesive the bonding of this paper bulk. The second thing is it can be a very good tool for design validation, and because first thing first, because it's faster, and second thing, sometimes even comparing with some developing countries, I would say we may, depends on design, we still would have benefit on cost. We can use in a cheaper manner just on the material cost to print out this thing and do the design validation. And then it's a very good bridging tool from design to the mass production. And then lastly is if just require maybe dozens of or let's say small few hundreds parts, tools, one tool is good enough. One 3D printed tool probably is good enough for you. Right, then we go to metal. Not all the packaging looks like plastic, right? Some of the packaging looks like metal. Like here is the tea bag, a tea can, and this tea can, how he get manufactured is actually used by the sheet metal forming method. It's like a one flat sheet metal, then use different patterns so they can form to a can design or can geometry. And with doing that, you actually require another kind of pattern to do that. And our material is also able to help to make the pattern, and is strong enough to to press on to leave some patterns on those sheet metal forming application. Yeah, then we go to case study. So first one is the Lipton I just show in the first few slides. And the reason they choose this Markforged as this application supplier is because Markforged can give a faster response time. When they have the part broken, they can just print it out, and also it doesn't require a MOQ on this particular part. When it broken, you can print on spot, then place on it. Then you can eliminate some of the storage costs as well. And also the machine itself is very, very easy to use. Actually, it's just one technician with a few hours training, you're able to do that. Another case study is the vacuum gripper. And this whole part here you see is made by Markforged. And like I mentioned, that you can embed this this channel, internal channel, to to our parts and apply it here. It's definitely very durable for holding this such a multiple the, the cover or the cap in one time. Right, and back to this this picture I showed in the first place, first few slides. It's actually one of our strategic account that we still try to develop more opportunities in both Europe and APAC. So the story actually starts with 1X7 in Europe, and we help them to, Markforged actually helps them to develop a e-cataloging system, and also help them to adopt our cloud software called Eiger. And for the same case, because actually it's a worldwide water manufacturing brands quite famous, and the reason they are worldwide is also partially is because the whole production line, they use whatever things in Europe, they use whatever things in Asia, like in Japan or in China. So in that case, actually, all these suppliers for the conveyor, to support the conveyor to run smoothly, is all come the same suppliers. And those suppliers earn a lot of bunch of money based on this company's operation. So in 2020, once they're aware that there's an X7 Markforged printer in Europe already been purchased, and they develop a lot of parts that can be used on their conveyor lines. So we just try to copy and paste in APAC in last year. And due to COVID and actually due to COVID and the import restriction, actually it really accelerated the adoption of using additive manufacturing. They have one plant in Indonesia, and for some of you may know that if for Indonesian company, in order to import some parts, the custom is not that efficient like Singapore or maybe your country or maybe Australia. So it really hindering the whole supply chains for Indonesia to get the parts on time from Europe. So in that case, they're thinking about different manner of doing that in-house or within the region. So a lot of local vendor being developed, but still evaluating the local vendor is another issue, right? So so now they have they realize there is a manufacturing engine that they can purchase the equipment and then do this exactly the same thing like what Europe did in their own local region. That is definitely a plus. And because COVID actually, they suddenly have more freedom and to explore how to do that. And till now, I would say it's already more than 100 parts being identified and just for a few months development. And there are 4 factories in one country, and they realize there's still a lot of parts in common, and they work together on identify different parts in their own factories by using our printers. And although there's more than 100 parts being identified, but there's actually, I would say 20, I think 30 plus parts have been already printed and tested on the line and see whether they can be used for long-term and short-term ways, lifetime, or anything need to be improved. And all of them, I would say they are all spare parts in production conveyor. There's nothing about prototypes and nothing about final part. All of them are the production part in conveyor, because their purpose of using this technology is try to avoiding the huge change, fluctuate the demand on supply chain, and they can more rely by themselves. So I mentioned there's a 30 plus parts, right? So there's some of the part I put here as a best practice. One of part it give a very extreme lead time saving result. Previously, they need to have 12 weeks to get from Europe, and right now they can print within a week to have the part and do it online, do it assemble on the part on the conveyor. Another extreme cost saving example is one part used to cost from the OEM is 2.5 thousand euro, and now by the printing itself is about 200 euro. And the last one is the extreme quantity with a positive Markforged printing cost saving. Just one part particular, 12 12,000 pieces per year. And with these 12,000 pieces per year, they can justify 2 Mark IIs purchase because they can save such huge money from this 12,000 pieces in a year. So if you talk to Markforged or Markforged reseller in your region before, you probably may see this these lines, and this line is actually talk about how the value shift from the very beginning about adopting 3D printing until at the end, how this 3D printing business is going to impact the customer's business. And I would say for this company, they are right now at the stage 2 and 3. They start to see the value of supply chain, and now they are seeing the more different ways or different manner or identify different parts in their factories to get the production be more agile and be a faster, responsive supply chain comparing with their competitors. So in the meantime, you can see inside their organization, they already have a 3D printing leads team, and also it's distributed to multiple regions, not just in Europe or APAC, maybe I think North America also have. Like it's a global initiative already, but it still haven't reached to like a centralized resource, but they start to have some 3D printing center of excellence, have different printers in their house and try to print things, and also see the possibility for one part instead of just use exactly same design from OEM, they try to optimize the design to follow the Markforged design guide. So that's all happening right now for this company, and they really receive the benefit on that. Okay, and also lastly, this is a final example, is a lean machine and the process improvement drive benefit. So the company is called Lean Machine as a contract manufacturer, and the 3D printing helped them to create a higher yield manufacturing cell in a day instead of weeks. And what you see here is actually for some, this is, you can see sheet metal forming or like a bending machine is for helping to, and here it can be 3D printed. And also here the end of arm by use robotics to do this operation, and also after that they do the QC check. Both of them, they use this robot arm, and here this like scissors-like parts and effectors is made by our stainless steel, and they can use really for a long time. So that's pretty much all there's a video about that. Take a look. So this scissors-like metal effectors is made by Markforged Metal Print. Okay, they finish the bending, the second bending. It also represents the precision or the quality of our print. Like one pair and you print another pair and use on the same operation, it shouldn't have a lot of much deviation. All right, that's pretty much all I have about this food and beverage. And here is a reminder that probably if you're interested about how 3D printing going to adopt in defense industry, you are more than welcome to register and join our next webinar. It's the third webinar for this whole series. Going to start at 24th March, and the host will be Alan Yu, my manager for application engineering in Markforged. So with that, I will hand it to Adam to talk about some government funding that you can use on adopting this technology, and hopefully can make your journey be easier. Adam, take it away.
Hi, thanks. Yes, so my name's Adam. I'm from Ernst & Young, and I'm in the government incentives team. And today I just want to talk to you about some of the opportunities which are available in the government funding landscape. And this is, I'm afraid, specific to Australia, but does broadly relate to the food and beverage industry. So we're looking at ways you can align your projects in your pipeline with different sources of funding. So while there are thousands of funding opportunities out there, billions of dollars, today I'm just going to talk about one specific area, and that is the Modern Manufacturing Initiative. So as you can see on the screen there, it's $1.3 billion across 6 national manufacturing priorities. one of which is the food and beverage industry. And this funding is split across 3 streams. So as you can see on the screen there, you've got first, which is collaboration. And this stream of funding is aimed at providing capital for very large research projects to support business to business and business to research collaborations. The second is the translation stream. This is aimed at commercializing and investment in non-R&D innovations. And the third is integration. So this is aimed at assisting manufacturers to integrate into local and international markets and supply chains. So for each of the national manufacturing priorities, when funding is opened, the government is releasing a priority roadmap, and these provide more clear vision on the specific growth areas that are being targeted for each category. So for beverage and food, the funding is not actually open yet, but it does mean that it's an ideal time for you to be identifying projects that are in your pipeline, which might align with these broader funding objectives. It is worth noting here that grants open and close very quickly. 3 of the manufacturing categories have already opened, and they have roughly a 1-month window for applications. So having a well-formulated and a well-defined project will increase your chances of success on this. Just go to the next slide, please. Thank you. So as I was saying, 2 of the streams will likely be open in the next week or so and are worth flagging for your attention. So the first is the translation stream. And this is where government is looking to back manufacturing businesses in strategic projects that will increase commercialization, embrace technology, innovation, and automation. They're looking to fund areas that are trying to grow production and bring commercial outcomes to new or existing markets. The integration stream is looking to achieve similar targets, but they're looking to invest in projects that will increase a manufacturing business's participation in new local or global value chains, again, embracing technology, innovation, and automation. Applications for these grants will be competitive, and your assessments will be determined based off key merit criteria. So there are 3 of these. The first is the alignment of your project to the program and the objectives therein. So a sample of which is already shown on the screen. Once the priority roadmaps are released, we'll have a better indication as to how your project might fit each of the different streams. The second area of merit criteria is the capacity, capability, and resources for you to deliver the project. And the third is the impact of the grant funding on your project. So on that topic, it is worth noting that the funding structure for the MMI is a 50% co-funding, and it looks to offer between $1 and $20 million for projects. So just to clarify, that's a total minimum spend of $2 million for project expenditure. Next slide, please. I think you may have skipped a slide. Yes, okay, great. So this is about eligible expenditure. So in your $2 million, what is exactly covered? So the first is plant and equipment. And this can cover things like designing, acquiring, installing, or the construction of new plants and equipment. It can also include software, but only where the software is required to facilitate the, implementation of the project. You can include your labor costs, so that would be direct labor costs, as well as technical project management and where you get third parties involved as contractors. You can cover your prototype costs, where you're looking to prove that you have a commercially viable and unique product, or in the IP patenting process therein. And finally, you have travel and a smattering of other costs. So this could be domestic or overseas travel, building modifications, staff and training, similar sorts of categories to that. And on the last slide. Okay, so if the streams of the MMI do not specifically align with your projects, there are other funding opportunities that are available. You may wish to explore more of a research focus, so that would be along the lines of the CICP, or you might be focusing more on increasing job creation. If you don't want to go towards more of a grant source of funding, you can look towards the R&D tax incentive, which is a bit more of a retrospective perspective, rather than looking at forward planning for your pipeline. Please be aware, though, that these are just a snapshot of current funding opportunities, and they are Australian specific. The funding landscape changes frequently, so keeping in mind projects you have in your pipeline and how they might align. It's just good to have that project list there and to constantly compare to funding that's coming out. If you have a project that you think might align to any of the funding opportunities that I've discussed and you want any assistance in scoping or preparation of an application, please reach out to me on the contact details there. Alternatively, if you are not from Australia and you have a project that you think may be eligible, again, please reach out and we can access our broader EY network and see how we might be able to help you out. Thank you very much for your time.
Thank you, Adam. I think the reason we have Adam here is to let you know that what are the options for you to easier adopt this, since the local government, example like in Australia, have such funding to support all the initiative, and we do see the similarity that we, as our company's mission, to really empower all the manufacturer in different industry to adopt the more advanced technology to help them to have more agile supply chain. Cool. So there will be everything they have. So we now open for Q&A. So audience, please, Mr. and Miss, please look at the bottom of your Zoom window. You have a Q&A button, so you can put all your questions there. So together with me, Adam, and also my colleagues, Alan, we are here. So if you do have any questions, feel free to shoot it out. Okay, I have one question from Anonymous. How is the precision of the parts produced by 3D printing? So it depends on the technology I mentioned. That right now we have composite and metal. So for composite, we're talking about plus minus for the full range of the part, meaning that the biggest size that we have is probably like a plus minus 125 micron per axis. And then when we if it goes to metal, is a little bit larger tolerance. Is in a certain single axis is every 25 millimeter. We have plus minus 125 micron. Right. Another question from Anonymous: is the recording available for the session? Answer is yes. So feel free to drop the email to the Markforged team, and we will send the record to you. Okay. Okay. Also, anonymous attendees. Seems like they have a lot of anonymous attendees. So, what are your printer facility located right now? Australia, Asia, which locations? We have the printing facilities. We have all the places you mentioned here. We have printing facilities, and most of the place we rely on the channel partners to do the supporting on those 3D printing business in local manner. Okay, and another question from Anonymous: what material can be printed? PLA, ABS, etc. Okay, our material for composite itself is called onyx. It's actually a nylon, or you can say a polyamide PA6 material with chopped carbon fiber. So the strength itself is almost like a 1.4 times stronger than a normal ABS 3D printed material. And what's more is we have a reinforced material called, it can be carbon fiber, a Kevlar, or glass fiber, or high strength, high temperature glass fiber, which can give like somehow equivalent to like a soft metal, like C series aluminum strength. So that is actually our composite strength at. And I guess you're asking about plastic, the non-metal material. So that's the options we have. Andrew asks, can Markforged 3D printer print food? This is another huge market. Yes, you're right. But Markforged at this moment is more focused on the robust tooling application. So we haven't reached out to food industry in particular, but more like manufacturer tools, or like final parts, components printing. Jaffa is asking, in blow molding, what are the concerns regarding to use HSD enforced material in the mold that can share a sample in Eiger? For sure. Just a brief answer that the reason we use HSHD is one thing because of the pressure. Second thing is because of the temperature. Usually our reinforced material can last is like 100 plus only, but our HSHD fiber can last like 150 degrees Celsius. So there is the highest temperature that we can last in our all reinforced material. So that's the reason we choose that. And if you do have some blow molding, want to discuss offline, then feel free to shoot me an email. It's chen.lee@markforge.com. Then we can discuss offline with Eiger, definitely. Anonymous, certainly. Do you have any experience in rigid packaging like plastic bottle and cap? You see, actually, just now there's some presentation saying that one thing is like deliver the caps. The other thing is making like a metal box for the tea package. These are or even like a plastic bottle, like just now I mentioned the vacuum forming. Now all these are in the rigid, so-called rigid packaging category, and we do have interference with that. Toby is asking, have you experienced in a 3D process components, example like a valve and the components? And if so, how is food quality issue addressed? Reduce service and service integrity. I would say most of the time still our customer using like in the packaging process, not on the direct food contact process. So from there, you can actually eliminate the hassle on for identifying or evaluating if this part itself is kind of food safe grade. Is it possible to use 3D printing for F&B mass production instead of just specific parts? Yes, but if food and F&B mass production, if you talk about the end product like printing food or printing drinks, is not what we are specialized to, but we are more specialized on printing the tooling or the final packaging. But also if you talk about the packaging itself, if you want to print by 3D printing material, you need to think about how about the cost effectiveness, if this really makes sense for you to do a mass production on the boxes printing by 3D printing. At this moment, unless your box have a very unique design or geometry that actually makes the mass production cost is very high. Otherwise, I don't think we can match on, you know, like manufacturing one box is like pretty cheap, like a few cents only. So that is something we can't reach at this moment. How many food and beverage company going for the 3D printing in terms of Markforged? I can't represent the worldwide Markforged, but in APAC we do see a significant growth on there, especially a lot of big F&B companies. They have like a beer manufacturer, food is like snacks manufacturer, and water manufacturer and yogurt manufacturer. All different kind and different kinds and all different locations in Asia. Even like I mentioned, like just now example like in Indonesia, like not very high labor country, but they still do see the value on using 3D printer. Do you have an R&D facility team can support to explore printing solutions such as trial printing of machine parts and tests on equipment? Thank you for asking that. We do have our product team, and actually Markforged, I would say, is very focused on hearing customer. Last night we just finished our voice of customer meeting, try to get the feedback from the field to understand what exactly you guys want. So if you do have those kind of inquiry, feel free to reach out to us. And pin us. Either you can find someone in LinkedIn, or if you know our email address, you can just reach out to us for that. And answer is yes, we can support. You match what model mostly use of Markforged printer in food and beverage company. The star model will be Mark II for desktop series and X7 for industrial series. So Mark II and X7. Can you please write your email here? Yes, for sure. Sorry, let me write my email here. This is my email. So if you want to discuss on applications, feel free to reach out. Sorry, short of a D. Okay, there you go. Right. How 3D printing will be cost and time effective comparing with the current method? So two things. Sometimes we can match both cost and time effective, but sometimes only can do one saving at one moment. So it depends on the parts. And as I mentioned, there's multiple different parts. And you will be surprised that some of the parts actually cost very costly from the OEM. Like there's one part we print is like within a day, we have a pair of a gripper for holding the bottle. And that is easily can cost like 2-digit, 3-digit or 4-digit from Europe, from a European OEM to give the original part. So that is where we can save the cost and money at the same time, because we eliminated the whole supply chain. So here actually, when we talk about cost, we are using the material cost from 3D printing versus the cost of logistic, the raw material, the OEM code, the logistic, the paperwork, and your labor cost, and also your storage cost at the same time, because that is what all the benefits across the using the additive manufacturing in-house. And time effective, same, like using a printer in-house versus the whole supply chain lead time. So there is how we compare and contrast on the cost and time saving. Right. Anonymous, for the vacuum gripper example, do you have also print the actual rubber or flexible gripper, or just the housing? So we do print flexible gripper, and we're not printing the rubbery material, but like I mentioned, we also print O-ring. We use nylon to replace the Teflon O-ring, but it's not rubbery, but it also has certain flexibility that can be done also. Okay, UMatch, can you reduce the material price? It's a matter of, it's a question about, it's a decision from my management. I need to check with them, but at this moment, from what I know, is we don't have any plan on reducing the material price. But we hear you. Definitely will feedback to management about that. Besides nylon, do you use ABS filament for 3D printing? Not at this moment. So actually, our strength is on composite printing. It's not on plastic printing. So if you do want to use like a very high strength requirement, or sometimes you see ABS or PLA material, the general 3D printing material, can easily get snapped, or printing in halfway it will get some warpage. That is where you should consider Markforged as another option or alternative to help you eliminate those hassle and print real strong part and directly use at the same time. Senkam asking, what is the ultimate density you typically get with steel? So the density usually we get is surrounding like 96%. Zhizhuang is asking, are you able to print tray prototypes? So are you talking about like the prototypes for the tray that holding the fruit, or that's what you're asking? The answer is yes, we can print whatever we want, provided this is the size is within our printing envelope. Then yes, we can do that. Anonymous asks, can you send me more info on printer blow molding? For sure. Feel free to reach out to myself. You have my email on the screen already. Then I will send the info to you after that. Other than the batch size, what are the actual benefits of the X7 over Mark II? There's multiple benefits. So first of all, material options. You have more material options to use on X7 than Mark II's. Example, like a fire redundant material. it's like a it's fire distinguished material. It will be self distinguished the fire within 10 seconds with a UL identification V0 certification, and also the envelope is better, and the printing speed is faster. And moreover, the reason that X7 is called industrial series is because it have a laser inspection features in the machine, and that will maintain your printed part result become more constant and also more precise, because that is the laser inspection itself is, we are talking about single micron precision. Will Markforged make SLA or SLS machine soon? Definitely not soon, because I never heard about it, any plan about SLA or SLS at this moment. Has Markforged mastered the shrinkage factor for binder jetting machines through algorithm? And if yes, would Markforged recommend this as a form of serial production? Form of serial production, you mean mass production? I would say this definitely will have advantage and disadvantage for Markforged composite printing comparing with binder jet printing. Reason for that is because for binder jet printing, the effectiveness actually should be faster than the traditional, the normal FFF or FDM. And similar for us, we are CFF or we call CFR. So yes, we can do mass production in a sense, but it won't be as effectiveness as that technology. But you are right, in terms of the shrinking factors, actually we have more well control. That is actually because not the, I won't say it's an algorithm of the software, but it's actually the material itself have certain magic features. So when I first cited about Markforged printing result, I was overwhelmed because I didn't expect a FDM printer print like a whole open system, no matter what kind of size. There's no warpage at all. And I'm now working in company for like 3 years. I almost never see any warpage during printing if you have the right design on the Markforged printer. All right. Can Markforged be print rubber? No. For your machine can print what size part? Please reach out to me or if you can find a local partner, then we will send you the specs for all the machines. Then you will see that which machine is more suitable for you based on the size or the printing capability. So what technique was used to produce the vacuum holder robot structure? How are the internal surface like? Are the products all full of crevices? Will there be airflow problem because of these factors? Potentially, I won't say there's a problem because okay. So first of all, definitely there will be certain leakage on the printing element, but if you apply vacuum directly. But there's two ways to eliminate or make the thing works. One thing is you can still enlarge the level of vacuum suction so that you still can maintain the vacuum suction in that particular area or the suction point that you want to add. Or another way is you can add the vacuum tube inside the internal channel, so that one thing you can save the time, or you can make the whole environment more tidier. But still you can perform the same performance. And your first question is the techniques is using the basic composite printing techniques, and it can print the onyx, which is the PA6 with chopped carbon fiber with continuous fiber together. Cool. I guess we answered 20 plus questions. All right, there you go. What are local partners for Markforged in Singapore? I'm based in Singapore, so feel free to reach to me, then I will link you with our local partner. And they do have all the series of printers in Singapore, so we can conduct a face-to-face meeting. Okay, so just now it's 11 o'clock. I hope again, first of all, I should thank Adam for joining this webinar, and for all the audience as well. Thank you for joining. And if you do have more questions for Mark Forge and also for Adam, just reach out to us after this webinar. And looking forward to see you guys in the next webinar, which is here, 24 of March. And Alan will be there to give you more insight about defense industry. Thank you so much, and talk to you guys soon. Bye.